Imagine you are on a silent spaceship, drifting through the vast, dark void between the galaxies. You've been traveling for 100 million years, and you are approaching your destination. In the distance, it looks like a faint, fuzzy star. As you get closer, it resolves into a beautiful golden-hued galaxy, a soft, round swarm of billions of old yellow stars, all held together in a calm, gravitational dance. It looks like a normal, if very old, elliptical galaxy. But as you get even closer, you realize something is deeply and profoundly strange. Surrounding this ancient golden core, separated by a vast ring of almost complete emptiness, is another structure. It is a perfect, brilliant, and impossibly delicate-looking ring of vibrant, young blue stars. It's a cosmic bullseye, a golden core, a gap of darkness, and a shimmering blue halo. The two parts seem to have nothing to do with each other. The core is ancient, the ring is young. They are moving together through space, but they seem to be from two different universes. This isn't science fiction. This is a real place. It is one of the strangest and most beautiful objects we have ever found, a quiet, enduring cosmic puzzle. Part 1. A cabinet of cosmic curiosities, peculiar objects and places. Our first exploration on this journey into the unknown is that very object, Hogg's object. Discovered in 1950 by an astronomer named Arthur Hogg, it has baffled scientists ever since. Hogg himself initially thought it might be a trick of the light, perhaps a gravitational lens where the gravity of the foreground galaxy was bending the light of another, more distant galaxy into a ring shape. But further observation showed that this wasn't the case. The core and the ring are at the same distance from us, about 600 million light-years away. They are a single, bizarre object. So the first great mystery is, how did it form?
The structure of Hogg's object is what makes it so deeply puzzling. Let's take a quiet, closer look at its anatomy. The central core is a beautiful, tightly packed ball of mostly old yellow stars. It looks very much like a typical elliptical galaxy, a galaxy that has used up most of its gas and is no longer forming new stars. It is a sedate, retired galaxy. Then there is the gap, a vast, dark ring of space, about 75,000 light-years across, where there is very little visible matter. This profound emptiness is one of the most striking features. Why is there nothing connecting the core and the ring? And then there is the ring itself. The outer ring is a stark contrast to the old core. It is a brilliant, blue, knotty circle, about 125,000 light-years in diameter, slightly larger than our own Milky Way. The blue color tells us that it is a region of active, recent star formation. It's filled with hot, young, massive blue stars. It's a place of cosmic youth and vitality. So, you have an old, retired galaxy at the center, and a young, active galaxy forming a perfect ring around it, with a huge, empty moat in between. It's as if two different galaxies from two different eras of the universe have been placed together in a perfect, impossible arrangement. This leads us to the central question: what kind of cosmic event could possibly create a structure like this? Over the decades, astronomers have come up with a few theories, but none of them fit perfectly. The object remains a quiet, beautiful anomaly.
The leading theory for how most ring galaxies form is called the bullet theory. The idea is that a smaller galaxy passes directly through the center of a larger, flat, spiral disk galaxy. The gravity of the smaller bullet galaxy as it passes through would disrupt the disk, creating a ripple effect, like dropping a stone into a quiet pond. This ripple, a wave of compressed gas, would then travel outwards through the disk, triggering a burst of star formation as it goes, creating the bright blue ring. This is a good theory, and it explains many other ring galaxies we've seen, but it has one major problem when it comes to Hoag's object. There is no sign of the bullet. We have searched the region around Hoag's object with our most powerful telescopes, and we can find no trace of any other galaxy that could have passed through it recently. If a collision happened, it must have happened billions of years ago, and the culprit has long since fled the scene. But if that's the case, it's hard to explain why the ring is still so neat and well-defined. This lack of evidence for a collision has led to other, more exotic theories. One idea is that Hoag's object was once a barred spiral galaxy. This is a type of spiral galaxy that has a large bar-shaped structure of stars at its center. The theory goes that perhaps the bar in this galaxy became unstable and eventually dissolved or broke down. The momentum from the dissolving bar could have then pushed the spiral arms outwards, causing them to form the detached ring we see today. It's a difficult theory to prove, but it would explain the lack of a second galaxy. For now, the true origin of this beautiful, lonely object remains one of astronomy's most quiet and elegant mysteries.
Let's leave this strange, singular galaxy behind and drift now to another cosmic mystery. This one isn't about the shape of a galaxy, but the strange behavior of a single, seemingly ordinary star. Our next exhibit in the Cabinet of Curiosities is Tabby Star, officially known as KIC 8462852. The story of Tabby Star begins with the Kepler Space Telescope. Kepler's mission was to find exoplanets by staring at a single patch of over 150,000 stars, looking for tiny, regular dips in their brightness caused by a planet passing in front. The amount of data Kepler produced was so enormous that astronomers enlisted the help of citizen scientists through a project called Planet Hunters. These volunteers would look at the light curves, the graphs of a star's brightness over time, searching for the telltale periodic dips of a planet. In 2015, these citizen scientists flagged one particular star as being very, very strange. It was a fairly normal F-type star, a little larger and hotter than our Sun, but its light curve was unlike anything anyone had ever seen. It didn't have small, regular dips like a planet would cause. Instead, it had a series of deep, brief, and completely irregular dips in its brightness. And most dramatically, it had two large, complex dimming events where the star's light dimmed by a staggering 15% and then 22%. A planet the size of Jupiter would only block about 1% of the light. Something huge, or a swarm of many somethings, was periodically passing in front of this star, and it wasn't following any predictable orbit. The star was immediately nicknamed Tabby Star, after the lead author of the scientific paper that described it, Tabitha Boyajian.
The mystery of Tabby Star is all about what could possibly be blocking so much light in such a strange and unpredictable way. Let's quietly explore some of the natural explanations that have been proposed. The first and most popular idea is that the star is surrounded by a massive, irregular swarm of comets. The theory goes that perhaps a gravitational disturbance from a passing star knocked a huge number of comets from the outer reaches of the star system inwards. These comets would now be in a chaotic, eccentric orbit around the star. As this giant cloud of cometary debris passes in front of the star, it would block the light, creating the strange dimming events we see. This is a plausible idea. It would explain the irregularity of the dips, as the comet swarm would be clumpy and uneven. However, there's a problem. When comets get close to a star, their ice should vaporize, creating a huge amount of infrared radiation, or heat. And when we've looked at Tabby Star with infrared telescopes, we don't see the strong infrared signal that a giant swarm of comets should be producing. So, while it's a good idea, it doesn't seem to perfectly fit all the data. Another possibility is that we are witnessing the aftermath of a colossal collision between two planets or protoplanets in that star system.
Such an event would create a massive, chaotic cloud of dust and debris, which would then orbit the star and could cause the dimming events. This is also a plausible idea, but such events are thought to be very rare, and the debris should eventually settle into a more regular orbit, which doesn't seem to be happening. The mystery of the dimming persists, a quiet and deeply puzzling stellar behavior. Other natural explanations for Tabby's star have been considered as well. Perhaps there is a large planet with a huge, unstable ring system, much larger and more chaotic than Saturn's. Or perhaps the star itself is intrinsically variable, with strange things happening on its surface that cause its brightness to change. However, the star's spectrum looks perfectly normal for a stable F-type star, making this explanation unlikely. Because none of the natural explanations seem to fit the data perfectly, it led some astronomers, and especially the media, to consider a much more exotic and exciting possibility. This was the alien megastructure hypothesis. The idea was put forward that perhaps what we are seeing is not a natural phenomenon at all, but a sign of a highly advanced, intelligent civilization. The concept is that a very advanced civilization would eventually need more energy than their home planet could provide. To get more energy, they might begin to build colossal structures in orbit around their own star to capture its light. This could be a Dyson swarm, a huge collection of giant solar panels and habitats orbiting the star. From our perspective, as this swarm of artificial structures passed in front of the star, it would block a significant amount of light, and because the swarm would be complex and irregular, it would do so in a non-periodic way. It's an incredible thought, and it's what made Tabby's star famous around the world. It's important to say that this is very much a hypothesis of last resort. Most scientists believe there is almost certainly a natural explanation for the star's dimming that we just don't understand yet. But the alien megastructure idea is a fascinating thought experiment. It's a quiet reminder that when you are faced with a true cosmic mystery, it's worth keeping an open mind to all the possibilities, no matter how strange they may seem.
Now, let's leave Tabby's star and its enduring mystery behind and travel to another object that presented us with a completely different kind of puzzle. This is our next exhibit in the Cabinet of Curiosities, the first confirmed interstellar visitor to our solar system, an object named Oumuamua. The name is Hawaiian, and it means a messenger from afar arriving first, or scout. And that's exactly what it was. It was discovered in October of 2017 by the Pan-STARRS telescope in Hawaii. Astronomers tracking its trajectory quickly realized something incredible. It was moving far too fast to be in a stable orbit around our sun. It was on a hyperbolic path, meaning it had come from interstellar space, was just passing through our solar system for a brief visit, and was now on its way back out into the void, never to return. It was our first contact with a piece of another star system. This alone would have made it a fascinating object. But as astronomers studied it during its brief passage, they realized that Oumuamua was deeply, deeply weird. First, there was its shape. We couldn't get a direct picture of it, it was just a point of light. But by looking at how its brightness varied over time, astronomers could infer its shape. It was tumbling, and the huge rapid swings in its brightness suggested it had a very extreme elongated shape. It was thought to be perhaps 10 times longer than it was wide, shaped something like a giant cosmic cigar or a very thin, flat pancake. This is not a shape we expect to see in natural asteroids or comets, which are usually lumpy and potato-like.
The strangeness of Oumuamua didn't stop with its shape. Its color was a dark, reddish hue, similar to some of the organic, rich objects we see in our own outer solar system. This suggested it might have been exposed to intense cosmic radiation for millions or even billions of years during its long journey between the stars. It also appeared to be completely inert. As it passed close to our sun, astronomers looked for any sign of a coma, the cloud of gas and dust that forms around a comet as its ice is vaporized by the sun's heat. They saw nothing. Oumuamua was not behaving like a comet. It appeared to be a dry, rocky, or metallic object. But this led to the single greatest mystery of all. As Oumuamua began to leave our solar system, astronomers tracking its path noticed that it was not slowing down as quickly as it should have been. It was exhibiting a slight, non-gravitational acceleration. It was moving away from the sun just a little bit faster than the laws of gravity alone could explain. It was as if something was giving it a gentle, continuous push. For a comet, this would be easy to explain. The outgassing of water vapor and dust acts like a tiny rocket engine, giving the comet a gentle push. But Oumuamua had no visible outgassing. It had no tail. So what was pushing it? This is the central, quiet puzzle of this strange visitor. It was a bizarrely shaped object that was acting like a comet without being a comet.
The mystery of Oumuamua's strange acceleration has led to a number of fascinating theories. The more conservative and likely explanations try to find a way for it to be a natural object. One leading idea is that it might have been a nitrogen iceberg. The theory goes that perhaps Oumuamua was a fragment chipped off a Pluto-like object in another star system, a body with vast glaciers of frozen nitrogen. As this nitrogen iceberg got close to our sun, the nitrogen would have vaporized, creating the gentle push. And because nitrogen gas is transparent, it would have created an invisible tail that our telescopes couldn't see. Another idea is that it might have been an unusual type of comet with a strange composition, or that it was just incredibly porous, allowing gas to escape in a way that didn't create a visible coma. These are all plausible ideas that scientists are still debating. But the unexplained nature of its acceleration also led a prominent Harvard astronomer, Avi Loeb, to propose a much more speculative and exciting idea. He argued that Oumuamua could be an artifact of an extraterrestrial civilization. The gentle push it was getting, he suggested, could be from the pressure of solar radiation acting on an incredibly thin and lightweight object. In other words, it could have been a light sail, a type of spacecraft that we ourselves are trying to develop. Now, this is an extraordinary claim, and most scientists remain highly skeptical. They believe a natural explanation is far more likely. But the story of Oumuamua is a wonderful example of how a single strange object can spark so much scientific debate and imagination. It was our first fleeting glimpse of a messenger from another star system, and it turned out to be far weirder than we ever expected.
Let's now pull our view back from a single strange visitor to a huge mysterious force that affects our entire galactic neighborhood. Our next exhibit is a gravitational anomaly with a wonderfully ominous name, the Great Attractor. This is not a theory, it is a direct observational mystery. For decades, astronomers have been mapping the movement of galaxies in our corner of the universe. We know that everything is moving away from everything else due to the expansion of the universe. But when we look closely at the motions of nearby galaxies, we see something strange. They are not just moving away from us, there is a large-scale bulk flow. Our own Milky Way galaxy, the Andromeda galaxy, and our entire local group of galaxies are all being pulled through space in a single direction at a speed of over 2 million kilometers per hour. And it's not just us. Our entire Virgo supercluster, and even the larger Laniakea supercluster that we are a part of, all seems to be moving towards the same point in the sky. This indicates the presence of a massive, unseen concentration of mass, a colossal gravitational anomaly whose pull is dominating the movement of thousands of galaxies across a region of space hundreds of millions of light years across. This is the Great Attractor. The mystery is, what is it? When we look in that direction, in the constellation Norma, our view is heavily obscured by the plane of our own Milky Way galaxy. The thick gas and dust in our own galaxy create a zone of avoidance, making it very difficult to see what lies beyond. We know something huge is over there, with the mass of tens of thousands of galaxies, but we can't get a clear picture of it. It's a quiet cosmic mystery on the grandest possible scale.
a reminder that we are just a small part of a much larger cosmic dance, being pulled by unseen forces towards an unknown destination. Our final exhibit in this gallery of peculiar objects takes us to a place we have visited before, but we will look at it now only through the lens of pure mystery. This is the heart of a black hole. We have a wonderfully successful theory of gravity, Einstein's general relativity, that describes black holes with incredible accuracy. We have even taken a picture of the shadow of one. We understand what happens outside the event horizon, but the moment you cross that threshold, our understanding completely and totally breaks down. The interior of a black hole is the greatest mystery in all of physics. According to our theories, all the mass that falls into a black hole is crushed down to an infinitely small, infinitely dense point at the very center, called the singularity. But the concept of infinity is usually a sign that our theories are no longer applicable. It's a mathematical warning sign that says, we don't know what's happening here. What is the true nature of the singularity? Is it a point? Is it a different state of matter? Does quantum mechanics prevent it from becoming truly infinite? We simply do not know. The answer is locked away forever behind the one-way door of the event horizon. And this leads to an even deeper mystery, a profound paradox that pits our two best theories of the universe against each other. This is the black hole information paradox. According to quantum mechanics, information in the universe can never be truly destroyed. It can be scrambled, like burning a book, but in theory you could piece it all back together. But according to general relativity, anything that falls into a black hole is gone forever, its information completely erased at the singularity. So what happens when a black hole eventually evaporates via Hawking radiation? Does the information get out, or is it truly destroyed, breaking the laws of quantum mechanics? This is one of the deepest and most challenging unsolved problems in all of theoretical physics. The heart of a black hole remains the ultimate cosmic question mark.
All right. We've spent a lot of time exploring the strange and wonderful mysteries of the distant universe. For this next part of our quiet journey, let's bring our focus much closer to home. Let's explore some of the more subtle but equally fascinating puzzles that still exist right here in our own planetary backyard. We begin with our 13th exhibit, the Kordylewski Clouds. For centuries, we have known about the moon, our constant, loyal companion. But what if we have other, much more ethereal companions? In the 1960s, a Polish astronomer named Kazimierz Kordylewski claimed to have observed two very faint, very large clouds of dust orbiting the Earth in the same path as the moon. These clouds are thought to be located at two specific gravitationally stable points in the Earth-Moon system, known as the L4 and L5 Lagrange points. These are special places where the gravitational pull of the Earth and the Moon balance out perfectly, allowing material to collect and remain in a stable position. The idea is that over billions of years, cosmic dust has become trapped in these gravitational pockets, forming two vast, ghostly clouds that orbit the Earth with us. These clouds are incredibly faint and diffuse, far fainter than the Milky Way, making them almost impossible to see from the ground, especially with modern light pollution. Their very existence has been debated for decades, with some observations confirming them and others finding nothing. But recent studies using advanced modeling and sensitive cameras suggest that they are indeed real. They are our planet's secret, dusty, ghost moons, quiet companions on our journey around the sun.
Now let's travel out to the frigid edges of our solar system for our 14th mystery. This is the enigma of the Kuiper Belt Cliff. The Kuiper Belt, as we know, is the vast ring of icy objects that orbits the Sun beyond Neptune. It's the home of Pluto and hundreds of thousands of other icy worlds. Based on our models of how the solar system formed, we would expect the density of objects in the Kuiper Belt to just slowly and gradually peter out as you get farther and farther from the Sun.
But that's not what we see. At a distance of about 50 times farther from the Sun than the Earth is, the number of objects in the Kuiper Belt suddenly and dramatically drops off. It's not a gentle fade, it's a sharp, unexpected edge, a cliff in the population of celestial bodies. For some reason, beyond this boundary, there is almost nothing. Why does the Kuiper Belt seem to have a sudden, sharp edge? No one knows for sure, but it's a very active area of research. One of the most exciting, though still speculative theories, is that this cliff has been carved out by the gravity of a large, unseen planet orbiting far beyond it. This is the Planet 9 hypothesis. The idea is that a massive planet, perhaps 5 to 10 times the mass of the Earth, is orbiting in the distant, dark reaches of our solar system. Its powerful gravity could have swept through the outer Kuiper Belt, either ejecting objects from the solar system entirely or shepherding them into different, more stable orbits, creating the sharp edge that we observe. We haven't found Planet 9 yet, but this strange, quiet cliff is one of the most compelling pieces of evidence that it might be out there, waiting to be discovered.
And for our 15th and final mystery on this tour, let's turn to one of the most fundamental questions about our own home planet, the origin of Earth's water. When you look at our world from space, it is a brilliant blue marble. Our oceans are the single most defining feature of our planet and the key ingredient for the life that flourishes here. But where did all this water come from? The answer is surprisingly mysterious. The early Earth, when it first formed, was an incredibly hot, molten world. It was so hot that any water that was originally present in the rocks that formed the planet would have likely boiled away and been lost to space. So, the leading theory for a long time was that our oceans were delivered later. The idea was that after the Earth cooled down, it was bombarded by millions of water-rich comets and asteroids from the outer solar system during a period called the Late Heavy Bombardment. These icy bodies would have acted as cosmic water tankers, delivering the water that would eventually form our oceans. This is a very elegant theory, but it has some problems. When we have analyzed the water from comets that we've been able to study up close, we've found that the chemical fingerprint of that water, specifically the ratio of a heavy type of hydrogen called deuterium, doesn't match the water in our oceans very well. The water in many comets is too heavy. This has led to a competing theory that a significant portion of Earth's water was here from the very beginning. The idea is that water molecules were chemically trapped inside the minerals of the rocks that formed the Earth. As the planet formed and differentiated, this water was released from the mantle through volcanic activity, eventually condensing to form the oceans. The true answer is likely a combination of both. Some water was here from the start, and some was delivered later by asteroids, whose water seems to be a better match than comets. But this quiet, fundamental question about our own home is still a beautiful, unsolved puzzle.
And with that, our slow journey through the universe's cabinet of curiosities comes to a close. We have visited 15 of the most profound and beautiful mysteries known to science. We've seen perfect ring galaxies with no explanation, and stars whose light dims for no apparent reason. We've contemplated the nature of the invisible dark matter that holds our galaxies together, and the mysterious dark energy that is pushing our universe apart. We've listened for a single, fleeting wow in the static of the cosmos, and we've examined the strange, sharp cliff at the edge of our own solar system. Each of these puzzles is a quiet invitation to wonder. They are the frontiers of our knowledge, the places where our current theories fall short. And I find that incredibly calming. It means that the universe is not a solved book that we have finished reading. It is a vast, ancient library, and we have only just walked through the front door and begun to browse the first few shelves. There are endless wings filled with countless strange and wonderful stories still waiting for us to explore. The existence of these mysteries is not a failure of science. It is the very thing that makes science so beautiful and so necessary.
It is the engine of our curiosity. It is the quiet pull that encourages us to build bigger telescopes, to think of smarter theories, and to keep looking up at the sky with a sense of hopeful wonder. So as you drift off to sleep tonight, let these quiet questions be a soothing presence. Let your mind float in the vast empty space of the Bootes void, or contemplate the strange perfect geometry of Hoag's object. The beauty of these mysteries is that they don't require an answer to be appreciated.
So let's begin that deeper dive. Let's return to the very beginning of our journey and spend more time with these concepts to truly appreciate the depth of their mystery. We started with a vibrant scene of a radio telescope, listening to the quiet hiss of the universe. Let's think more about that hiss. It is the sound of reality itself. And the fact that it is so quiet, so devoid of any obviously artificial signals, is what makes the Fermi paradox so powerful. But the search for signals, the SETI project, is only one way we look for life. The other side of the coin is astrobiology, the search for life itself, in any form. And that search, as we've seen, has revealed that the potential for life is everywhere. So the paradox only gets deeper. Let's re-examine the very first mystery on our list, the fast radio bursts. We mentioned that some of them have now been linked to magnetars, but this has only deepened the mystery in some ways. The FRB that we saw from the magnetar in our own galaxy was powerful, yes, but it was a mere whisper compared to the extragalactic FRBs we see. The most powerful of these release as much energy in a millisecond as our sun does in 3 days. Can a magnetar flare really produce that much energy in radio waves alone? Or is there another, even more powerful mechanism at play? And then there are the repeating FRBs. One famous repeater, FRB 121102, flashes randomly, but sometimes multiple times in a single hour. It seems to be located in a small dwarf galaxy with a high rate of star formation, a place where you would expect to find young, active magnetars. But another repeating FRB was found in a place where it shouldn't be, near an old quiet globular cluster, a place with no massive young stars to create magnetars. This suggests that there might be at least 2 different ways to create these strange cosmic shouts. One involving young magnetars, and another involving something else entirely, perhaps the merger of old neutron stars, or something even more exotic we haven't thought of yet.
The next mystery on our tour is a story about particles that frankly shouldn't exist. These are ultra-high energy cosmic rays, or UHECRs. We've already talked about galactic cosmic rays, the constant drizzle of energetic particles from within our galaxy. But UHECRs are a different beast entirely. They are single, subatomic particles, usually a lone proton, that are traveling at a speed so close to the speed of light that their energy is almost beyond comprehension. The most famous of these was detected on the night of October 15, 1991, by a detector at the University of Utah called the Fly's Eye experiment. They detected a single proton that was so energetic it became a legend in the physics community. It was nicknamed the "Oh my God" particle. Let's try to put its energy into perspective. We measure energy in particle physics in units called electron volts. A typical cosmic ray from our galaxy might have an energy of a few billion electron volts. The most powerful particle accelerator we've ever built on Earth, the Large Hadron Collider, can accelerate protons to an energy of a few trillion electron volts. The "Oh my God" particle had an energy of 320 exa-electron volts. That's 320 quintillion electron volts. It was tens of millions of times more powerful than anything we can create on Earth. It was a single, solitary proton that had the same kinetic energy as a baseball traveling at 100 kilometers per hour. The mystery is simple and profound. What in the universe is powerful enough to accelerate a single proton to that incredible speed? What cosmic engine can create such a thing? We simply don't know. The usual suspects, like supernovae or even the jets from supermassive black holes, don't seem to have enough power to explain it. It is a quiet clue that there are particle accelerators in the universe far more powerful than we can currently imagine.
The puzzle of these ultra-high energy cosmic rays gets even deeper when you consider a concept known as the GZK limit. This was a theoretical speed limit for cosmic rays, figured out by physicists Kreisen, Zetsepin, and Kuzmin in the 1960s. The idea is that as a cosmic ray travels through the vast distances of intergalactic space, it isn't traveling through a perfect vacuum. As we know, space is filled with the faint afterglow of the Big Bang, the cosmic microwave background radiation. The GZK limit predicts that if a cosmic ray proton is energetic enough, it will inevitably interact with these low-energy microwave photons. These collisions will bleed energy from the proton, slowing it down. This effect creates a horizon for UHCRs. They shouldn't be able to travel for more than about 150 million light-years before their energy drops below the ultra-high threshold. This means that the source of the oh my god particle and the dozens of other UHCRs we've detected since must be relatively close to us in cosmic terms, within our local cosmic neighborhood. But when we look at the part of the sky they came from, we see nothing. There were no obvious candidates, no powerful active galaxies, no strange pulsars, no recent supernovae that could be responsible for creating them. So we have a profound mystery. We have these impossibly energetic particles hitting our planet, but they must be coming from somewhere nearby, and yet we can't find any source that's powerful enough to have created them. They are like impossible bullets fired from an invisible gun, a quiet and deeply puzzling cosmic riddle.
Now, let's turn from particles to radio waves and revisit a classic mystery in much more detail. This is the story of the WOW signal. Our tale takes us back to a quiet night, August 15, 1977, at the Perkins Observatory of Ohio Wesleyan University. There, a giant radio telescope nicknamed the Big Ear was patiently listening to the sky. The Big Ear was conducting a survey for the SETI project, the search for extraterrestrial intelligence. It wasn't actively sending any signals, it was just listening, hoping to catch a stray, artificial whisper from the cosmos. The data from the telescope was recorded not on a fancy digital screen, but on long sheets of computer printout paper, filled with columns of alphanumeric characters. A few days after that night, a volunteer astronomer named Dr. Jerry Eman was doing the routine and often tedious job of reviewing the printouts from the previous night's observations. As he scanned the columns of 1s, 2s, and 3s that represented the normal background static of the universe, his eyes suddenly caught a sequence that made him sit bolt upright. For a period of 72 seconds, the telescope had recorded a powerful, structured burst of radio waves. The signal was incredibly strong, at one point over 30 times louder than the background noise. It was a narrow-band signal, meaning it was confined to a very specific, clean frequency. And most tantalizingly, that frequency was at 1420 megahertz, the natural emission frequency of hydrogen gas. This is a quiet, protected band of the radio spectrum that many astronomers have theorized would be the perfect calling card frequency for an intelligent civilization to use. It's the universe's most common element, broadcasting on its own natural channel. Dr. Eman was so stunned, he circled the sequence on the printout, 6EQUJ5, and wrote the simple, honest word, WOW, in the margin.
The WOW signal remains, to this day, the single strongest candidate for a potential extraterrestrial signal ever detected. But it is a deeply frustrating mystery, because it has never, ever been repeated. In the days, weeks, and decades that followed, astronomers from all over the world have pointed their radio telescopes back to that same patch of sky in the constellation Sagittarius, listening intently,
they have found nothing but silence. The signal's characteristics are what make it so puzzling. Its 72-second duration perfectly matched the time it would take for the Big Ear telescope to observe a fixed point in space as the Earth rotated, suggesting a celestial rather than earthly origin. Its strength rose and fell in a perfect bell curve, exactly as you would expect from a distant source passing through the telescope's beam. And its narrowband nature was very different from the messy, broadband noise produced by most natural phenomena. So what was it? Over the years, many theories have been proposed. Could it have been a signal from an Earth-based source, like a military satellite, that reflected off a piece of space debris and into the telescope? It's possible, but unlikely, given the signal's specific frequency and structure. Could it have been a strange, unknown natural phenomenon, like a strange type of pulsar or an unusual interstellar scintillation event? Perhaps. More recently, a plausible, if less exciting, hypothesis has been put forward. It suggests that the signal could have been generated by the hydrogen clouds surrounding a passing comet. Two specific comets were in that region of the sky at the time. It's possible that their hydrogen clouds were stimulated in some way, producing a strong temporary signal. But this theory is also debated and doesn't perfectly explain all the signal's properties. So what was it? Over the years, many theories have been proposed. Could it have been a signal from an Earth-based source, like a military satellite, that reflected off a piece of space debris and into the telescope? It's possible, but unlikely, given the signal's specific frequency and structure. Could it have been a strange, unknown natural phenomenon, like a strange type of pulsar or an unusual interstellar scintillation event? Perhaps. More recently, a plausible, if less exciting, hypothesis has been put forward. It suggests that the signal could have been generated by the hydrogen clouds surrounding a passing comet. Two specific comets were in that region of the sky at the time. It's possible that their hydrogen clouds were stimulated in some way, producing a strong temporary signal. But this theory is also debated and doesn't perfectly explain all the signal's properties. So what was it? Over the years, many theories have been proposed.
All right, let's leave the world of strange signals behind and sink down into an even deeper and more profound layer of cosmic mystery. We are now entering a realm that makes up almost all of the universe, but is completely invisible to us. This is the world of dark matter and dark energy. We'll begin with our next exhibit, the invisible skeleton of the cosmos, dark matter. Everything we can see, the stars, the galaxies, the planets, you and me, is made of normal, baryonic matter. For a long time, we assumed that this was what the universe was made of. But starting in the 1960s and 70s, a brilliant and tenacious astronomer named Vera Rubin made a series of observations that would change our understanding of the universe forever. She was studying the rotation of spiral galaxies, like our own Milky Way. Our simple understanding of gravity tells us that stars farther away from the dense, bright center of a galaxy should be moving much more slowly than stars closer in, just like Neptune orbits our Sun much more slowly than Mercury does. But when Vera Rubin made her careful measurements, she found something completely wrong. The stars on the outer edges of the galaxies were moving just as fast, and in some cases even faster, than the stars near the center. This was a profound paradox. The galaxies were spinning so fast that the gravity from the stars we could see shouldn't have been enough to hold them together. They should have flown apart, their outer stars flinging off into the void. The fact that they were stable meant there had to be a huge amount of extra mass in these galaxies, something that was providing the necessary gravitational glue, but something that was completely invisible. She had found the first strong evidence for dark matter.
Vera Rubin's work was initially met with a lot of skepticism, but over the next few decades, the evidence from many other sources became overwhelming.
We see the effects of dark matter in the way galaxy clusters bend the light from objects behind them, a phenomenon called gravitational lensing. The amount of lensing we see is far greater than what the visible matter can account for. There must be a huge, invisible halo of mass there. We also see its imprint in the detailed structure of the cosmic microwave background radiation, the afterglow of the Big Bang. All of these different lines of evidence point to the same incredible conclusion. The normal matter that we are made of accounts for only about 15% of the total matter in the universe. The other 85% is this strange, invisible, non-interacting substance. Dark matter is the scaffolding upon which our entire universe is built. It is the invisible skeleton that galaxies form within. It is, by far, the dominant form of matter in the cosmos, and we have absolutely no idea what it is. The leading theories suggest that dark matter is made of some new kind of subatomic particle that we have not yet discovered. These hypothetical particles are often called WIMPs, which stands for weakly interacting massive particles. The idea is that these particles don't really interact with normal matter or with light at all, which is why we can't see them. They just drift through the universe and through us like ghosts, their presence only felt through their collective gravitational pull. To find them, scientists have built incredible detectors, deep underground in old mines, shielded from all other radiation, hoping to catch the rare, faint signal of a single dark matter particle bumping into a normal atom. So far, they have found nothing. The nature of the invisible universe that surrounds us remains a deep and profound mystery.
If the mystery of dark matter, the invisible stuff that holds the universe together, wasn't profound enough, our next exhibit is even stranger. This is the story of dark energy, the invisible force that seems to be pushing the universe apart. For most of the 20th century, cosmologists debated the ultimate fate of the universe. The Big Bang started everything off with a powerful expansion. The great question was whether the force of gravity from all the matter in the universe pulling on itself would be strong enough to eventually slow that expansion down, stop it, and perhaps even cause the universe to collapse back in on itself in a big crunch. Measuring the rate at which the universe's expansion was slowing down was one of the biggest goals of cosmology. In the late 1990s, two separate teams of astronomers set out to do just that. They were using distant supernovae as standard candles to measure the expansion rate of the universe at different points in its history. And both teams, independently, found something completely shocking, something that made no sense at all. The expansion of the universe was not slowing down. It was speeding up. It was accelerating. This discovery was so profound, it won the Nobel Prize in Physics in 2011. It meant that the universe wasn't just expanding from the initial push of the Big Bang. There had to be some other unknown force at play, a mysterious energy inherent in the fabric of space itself that was acting as a kind of anti-gravity, pushing everything apart. This mysterious force was given the name dark energy.
And here is the truly humbling part. When cosmologists did the math and calculated how much of this dark energy must exist to account for the accelerating expansion, they came to an astonishing conclusion. The normal matter that makes up everything we can see accounts for only about 5% of the total mass energy content of the universe. Dark matter, the invisible stuff holding galaxies together, makes up about 25%, and dark energy, this strange repulsive force we just discovered, makes up the remaining 70%. So our entire understanding of physics, everything we have ever studied, is based on the 5% of the universe that we can actually see and interact with. The other 95% of reality is composed of dark matter and dark energy, two substances that we know almost nothing about. We don't know what they are, where they come from, or why they have the values they do. We are, in a very real sense, strangers in our own universe, just beginning to glimpse the true, vast, and dark nature of reality. This leads us to our next quiet mystery, a place where the consequences of dark matter and dark energy are laid bare. This is the story of the Boötes Void, also known as the Great Nothing. As astronomers began to map the large-scale structure of the universe in the 1980s, they confirmed that galaxies are not spread out randomly. They are arranged in a vast, beautiful web-like structure. They cluster together in long, thin filaments and great walls surrounding vast, relatively empty regions called voids. But the Boötes void was different. It was far larger and far emptier than any model had predicted.
Let's just take a moment to quietly contemplate the scale of this place. The Boötes void is a colossal, roughly spherical region of space, about 330 million light-years in diameter. It is so large that it represents a significant fraction of the entire observable universe. Based on the average density of galaxies in the cosmos, a region this large should contain many thousands of galaxies. Our own Milky Way and its dozens of neighbors would be completely lost inside it. But when astronomers pointed their telescopes towards this region, they found almost nothing. It is a place of profound and almost perfect emptiness. To date, we have only found about 60 galaxies in the entire Boötes void, most of them clustered together in a strange tube-like structure that runs through the middle. If our own galaxy were located at the center of this void, the night sky would be a place of deep and almost absolute blackness. We would have had no idea that other galaxies even existed until our telescopes became powerful enough in the 1960s to see across that immense empty expanse. How did such a colossal void form? The best theory is that it's the result of smaller voids merging together over billions of years, their gravitational pull pushing the few galaxies that were inside to the edges, like foam on the surface of soap bubbles. But its sheer size still challenges our cosmological models. It is the quietest, loneliest place we have ever found. A humbling reminder that the universe is not a uniform city of stars, but a place of great walls and even greater, more profound emptiness. And from the greatest emptiness, let's now turn to the mystery of an unseen powerful pull. This is the story of the Great Attractor. As we've mentioned, our Milky Way galaxy is moving through space at an incredible speed. Part of this motion is due to the expansion of the universe, but when you subtract that expansion, there is still a residual motion. Our galaxy, the Andromeda Galaxy, and our entire local group are all being pulled in a specific direction. And it's not just us. Our entire Virgo supercluster, a massive collection of galaxy groups, is also being tugged in that same direction. This indicates the presence of a massive, unseen concentration of mass, a colossal gravitational anomaly that is winning the tug of war against the expansion of the universe in our local neighborhood. This is the Great Attractor. It's located about 150 to 250 million light-years away from us, in the direction of the constellations Triangulum Australe and Norma. The mystery is, what is it? When we try to look in that direction with our optical telescopes, our view is heavily blocked by the plane of our own Milky Way galaxy. The dense gas and dust in our own galaxy create a zone of avoidance, a band across the sky where it's very difficult to see distant objects. Using X-ray and radio telescopes, which can pierce through some of the dust, we have been able to see that the region is home to a massive galaxy cluster called the Norma Cluster. But even the mass of this huge cluster doesn't seem to be enough to fully account for the powerful gravitational pull that we are experiencing. The Great Attractor remains a partial mystery, a quiet, unseen force whose gravity is pulling thousands of galaxies, including our own, towards an unknown destination.
All right. Let's now drift away from the great, invisible mysteries of the dark universe and into a new gallery in our Cosmic Museum. This hall is filled with specific individual objects that we can see, but which are so strange and so unique that they defy easy explanation. These are the beautiful, quiet puzzles of the cosmos. We begin with our next exhibit, a galaxy that is one of the most aesthetically pleasing and deeply mysterious objects in the sky. This is Hoag's object. Discovered in 1950 by astronomer Arthur Hogue, it is a stunningly perfect example of a very rare type of galaxy called a ring galaxy. Imagine a bright, golden, perfectly round core. This core is made up of billions of old yellow stars, much like a small elliptical galaxy. Now, imagine a vast, empty gap surrounding this core, a cosmic moat with almost nothing in it. And then surrounding that gap, imagine a perfect, brilliant blue ring. This ring is made of hot, young, massive stars, a place of active star formation. The core is old and retired. The ring is young and vibrant. The two parts seem to have nothing to do with each other, yet they are a single gravitationally bound object, about 600 million light-years away. The mystery of Hogue's object is simple. How did it form? The leading theory for ring galaxies is a bullet model, where a smaller galaxy passes directly through the center of a larger disk galaxy, creating a ripple that forms the ring. But the problem is, we can find no sign of the bullet galaxy anywhere near Hogue's object. If a collision happened, it must have been billions of years ago, which makes the perfect structure of the ring hard to explain. It remains one of astronomy's most beautiful and quiet enigmas.
Our next strange object is a single, seemingly ordinary star that has caused an extraordinary amount of scientific debate and wonder. This is Tabby's star, or KIC 8462852. As we discussed, the Kepler Space Telescope found this star because it was dimming in a way that no other star had ever been seen to dim before. It wasn't the small, regular, periodic dimming you'd expect from an orbiting planet. It was experiencing huge, deep, and completely irregular dips in its brightness, sometimes by as much as 22%. Something enormous, or a swarm of many enormous things, is orbiting this star and periodically blocking its light. What could it be? The leading natural explanation is that we are seeing a massive, irregular swarm of comets. Perhaps a gravitational nudge from a passing star sent a huge cloud of comets from the outer reaches of that system careening inwards. As they get close to the star, they would release huge amounts of dust and gas that could block the light in the strange, clumpy way that we observe. The main problem with this theory is that all that dust and gas should be heated by the star and should glow brightly in infrared light. And when we've looked at Tabby's star with infrared telescopes, we don't see the strong infrared signal we would expect from a giant cometary swarm. Other theories include the aftermath of a planetary collision or strange dynamics within the star itself, but none of them perfectly fit all the data. This lack of a good natural explanation is what led to the famous, if highly speculative, alien megastructure hypothesis. The idea that we might be seeing a vast artificial structure being built around the star. While this is extremely unlikely, the mystery of Tabby's star is a wonderful example of a genuine scientific puzzle. A quiet, strange signal from a distant star that we do not yet understand.
Now, let's turn to a mystery that came to visit us. Our next exhibit is the strange and fleeting interstellar traveler Oumuamua. Discovered in 2017, this was the first object we've ever detected that came from another star system. It was just passing through, and it was deeply weird. First, there was its shape. By observing how its brightness changed as it tumbled through space, astronomers inferred that it had a very extreme, elongated shape, perhaps like a cigar or a flat pancake, 10 times longer than it was wide. This is very different from the lumpy, potato-like shapes of the asteroids in our own solar system. Second, it didn't behave like a comet. As it passed by our sun, astronomers looked for any sign of a coma or a tail of gas and dust being released from its surface. They saw nothing. It appeared to be a dry, inert, rocky object. But this led to the biggest mystery of all. As Oumuamua began to leave our solar system, it was accelerating. It was moving away from the sun just a little bit faster than gravity alone could explain. It was as if something was giving it a gentle, continuous push. For a comet, this non-gravitational acceleration is easily explained by the outgassing of ice acting like a tiny rocket engine. But Oumuamua had no visible outgassing. So what was pushing it?
Was it a strange new type of comet made of something like solid nitrogen or hydrogen that would produce an invisible tail? Or was it, as one prominent astronomer has speculatively argued, something else entirely? Could its acceleration have been caused by the gentle pressure of sunlight on an incredibly thin, lightweight object? In other words, an alien solar sail? We will likely never know. Oumuamua is gone forever, heading back out into the interstellar darkness, leaving behind a beautiful and quiet puzzle.
Our final exhibit in this gallery brings us back to a familiar subject, but seen through the lens of its deepest mystery. This is the black hole singularity and the information paradox. As we know, black holes are objects whose gravity is so strong that nothing, not even light, can escape once it crosses the event horizon. Our theory of gravity, Einstein's general relativity, has been incredibly successful at describing what happens outside the event horizon. But the theory tells us that inside, all the matter that falls into the black hole is crushed down to an infinitely small, infinitely dense point at the very center, the singularity. The problem is that the concept of infinity in a physical theory is usually a red flag. It's a sign that the theory itself is breaking down, that it no longer applies in these extreme conditions. What really happens at the center of a black hole? Does a new theory, like quantum gravity, take over and prevent a true singularity from forming? Is the matter converted into some new exotic state? We simply do not know. The ultimate answer is locked away from us forever behind the perfect prison walls of the event horizon. This leads to an even deeper mystery, a profound conflict between our two best theories of the universe. This is the black hole information paradox. Quantum mechanics, our theory of the small, has a fundamental rule: information can never be destroyed. But a black hole seems to do just that. If you throw a book into a black hole, all the intricate information that made up that book seems to be completely erased from the universe. This contradiction is one of the deepest and most challenging unsolved problems in all of theoretical physics. The heart of a black hole is not just a place of immense gravity. It is a place where our understanding of reality itself comes to a quiet and complete stop.
All right, we've spent a long time exploring the strange and wonderful mysteries of the distant universe. For our final chapter on this quiet journey, let's bring our focus all the way back home, to our own planetary backyard. Even here, in a neighborhood we've studied for centuries, there are still quiet, subtle puzzles waiting to be solved. We begin with our next exhibit, a pair of ghostly companions to our own planet. These are the Kordylewski clouds. For all of human history, we have looked up and seen one moon orbiting the Earth. But what if there are others, made not of rock, but of dust? The idea goes back to the 18th century, when mathematicians realized there are special, gravitationally stable points in the Earth-Moon system. These are called Lagrange points. An object placed at one of these points will stay there, orbiting the Earth in lockstep with the Moon. In the 1960s, a Polish astronomer named Kazimierz Kordylewski announced that he had observed two very faint, very large clouds of dust located at two of these stable points, the L4 and L5 Lagrange points. The theory is that over billions of years, cosmic dust from comets and asteroids has become trapped in these gravitational pockets, forming two vast ethereal clouds that are, in a sense, our planet's secret dust moons. These clouds are incredibly faint and diffuse, far fainter than the band of the Milky Way. This makes them almost impossible to see from the ground, especially with our modern, light-polluted skies. For decades, their very existence was debated by astronomers, but in 2018, a team of Hungarian astronomers published new research using special polarizing filters that confirmed the presence of these ghostly clouds. They are our quiet, nearly invisible companions on our journey around the sun.
Now, let's travel out to the frigid edges of our solar system for our next quiet mystery. This is the enigma of the Kuiper Belt Cliff. The Kuiper Belt, as we know, is the vast donut-shaped ring of icy objects that orbits the Sun beyond the path of Neptune. It's the home of countless comets and dwarf planets like Pluto. Based on our models of how the solar system formed from a swirling disk of gas and dust, we would expect the Kuiper Belt to just slowly and gradually fade away as you get farther and farther from the Sun. The density of objects should just peter out into nothingness. But that's not what we see. At a distance of about 50 astronomical units, that's 50 times farther from the Sun than the Earth is, the number of objects in the Kuiper Belt suddenly and dramatically drops off. It's not a gentle fade, it's a sharp, unexpected edge. It's as if you were walking through a forest and came to a sudden, perfectly straight cliff where the trees just stop. Why does the Kuiper Belt seem to have this sharp edge? No one knows for sure. It could be that there just wasn't enough material in the primordial solar nebula at that distance for larger objects to form. But a more exciting, though still speculative theory, is that this cliff has been carved out by the gravity of a large, unseen planet orbiting far beyond it. This is the famous Planet 9 hypothesis. The idea is that a massive planet, perhaps 5 to 10 times the mass of the Earth, is orbiting on a long elliptical path in the distant dark reaches of our solar system. Its powerful gravity could have swept through the outer Kuiper Belt over billions of years, either rejecting objects from the solar system entirely or shepherding them into different, more stable orbits, creating the sharp edge that we observe today. We haven't found Planet 9 yet, but this strange, quiet cliff is one of the most compelling pieces of evidence that it might be out there, waiting silently in the dark to be discovered.
And for our final mystery on this long tour, let's turn to one of the most fundamental and surprisingly difficult questions about our own home planet: the origin of Earth's water. When we look at our world from space, it is a brilliant jewel of blue and white. Our vast liquid water oceans are the single most defining feature of our planet, and they are the essential ingredient that allowed life to arise and flourish here. But where did all this water actually come from? The answer is a quiet and complex detective story. The early Earth, when it first formed about 4.5 billion years ago, was a very different place. It was a hot, molten world, constantly being bombarded by other planetesimals. It was so hot that any water that was originally present in the rocks that accreted to form the planet would have likely been turned into steam and boiled away into space by the intense heat and the solar wind from a young, active sun. So if our planet started out as a dry rock, how did it end up with oceans? The leading theory for a long time was that our water was delivered later, like a cosmic pizza delivery. The idea was that after the Earth cooled down, it was subjected to a period of intense bombardment by water-rich objects from the outer solar system. This late heavy bombardment would have brought millions of comets and asteroids, which are essentially dirty snowballs and wet rocks, crashing into our planet. These icy bodies would have vaporized on impact, releasing their water to form a dense, steamy atmosphere, which then cooled and rained down to form the first oceans. It's a very elegant and compelling theory.
This theory of cometary delivery was the standard model for decades, but as our science has gotten better, we've found a few problems with it. We have now been able to study the water from several comets up close, thanks to missions like Rosetta. And when we analyze the chemical fingerprint of that water, we find that it doesn't quite match the water in our oceans. Specifically, we look at the ratio of normal hydrogen to a heavier version, or isotope, of hydrogen called deuterium. The water in many comets has a much higher concentration of deuterium than Earth's ocean water. This suggests that while comets certainly delivered some water to Earth, they probably weren't the main source. This has led to a renewed interest in a competing theory, that a significant portion of Earth's water was actually here from the very beginning. The idea is that water molecules were not just on the surface of the early Earth, but were chemically trapped deep inside the minerals of the rocks that made up the planet's mantle. As the planet formed and its interior heated up, this water was released from the mantle through volcanic activity in the form of massive amounts of steam from erupting volcanoes. This volcanic outgassing would have created a dense, steamy atmosphere over millions of years, which then cooled and rained down to form our oceans. The true answer is likely a combination of both of these stories. Our oceans are probably a mix of primordial water from inside the Earth and water delivered later by asteroids, whose water seems to be a better chemical match than comets. But the exact ratio remains a subject of intense scientific debate. It's a quiet, fundamental puzzle about our own home, a reminder that even the most familiar features of our world still hold deep mysteries.
And with that final, quiet question about our own origins, our long, slow journey through the universe's cabinet of curiosities comes to a close. We have visited 15 of the most profound and beautiful mysteries known to science. We've seen galaxies shaped like perfect rings and stars whose light dims for no reason we can yet understand. We've contemplated the nature of the invisible dark matter that holds our cosmos together and the mysterious dark energy that is quietly pushing it all apart. We've listened for a single fleeting wow in the static of deep space, and we've examined the strange, sharp cliff at the edge of our own solar system. Each of these puzzles is a quiet invitation to wonder. They are the frontiers of our knowledge, the places where our current maps of reality have blank spaces labeled "Here be dragons," and I find that incredibly calming. It means that the universe is not a solved book that we have finished reading. It is a vast, ancient library, and we have only just walked through the front door and begun to browse the first few shelves. There are endless wings, filled with countless strange and wonderful stories, still waiting for us to explore. The existence of these mysteries is not a failure of science. It is the very thing that makes science so beautiful and so necessary. It is the engine of our curiosity. It is the quiet pull that encourages us to build bigger telescopes, to think of smarter theories, and to keep looking up at the sky with a sense of hopeful wonder and profound humility. So as you drift off to sleep tonight, let these quiet questions be a soothing presence. Let your mind float in the vast, empty space of the Boötes void, or contemplate the strange, perfect geometry of Hoag's object. The beauty of these mysteries is that they don't require an answer to be appreciated.
Let's return for a moment to that quiet control room in Ohio in 1977 and listen more closely to the wow signal. The sequence of characters that Jerry Emmons circled on that printout, 6EQJ5, looks like gibberish, but it's actually a very elegant way of representing signal strength. The computer measured the signal intensity every 12 seconds. A blank space meant no signal above the background noise. Numbers 1 through 9 represented signals 1 to 9 times stronger than the background. And if the signal got even stronger than that, it started using letters. A was 10 times stronger, B was 11, and so on. The sequence 6EQJ5 tells a story. It shows a signal that started at 6 times the background noise, then rapidly rose to E 14 times, then Q 26 times, then U 30 times stronger than the background noise. It peaked and then it faded just as rapidly back down to J 19 times and then 5. This perfect bell-shaped rise and fall is precisely what you would expect to see if a fixed, continuous signal source from deep space drifted through the narrow beam of the radio telescope as the Earth rotated. It's a beautiful, clean signal profile. The fact that it was so close to the hydrogen line frequency is what really made it stand out. This frequency,
1420 MHz is a protected part of the radio spectrum where earthly transmissions are forbidden to allow astronomers to study the natural hydrogen in our galaxy. The idea that another civilization would choose this quiet, universal calling card frequency to broadcast a beacon is a very old and very compelling idea in SETI research. The wow signal fit the profile of what we were looking for almost perfectly. It was a quiet, fleeting whisper that has echoed in our scientific imagination ever since.
Let's now spend a little more time with the mystery of ultra-high energy cosmic rays. The Oh My God particle was just the first. Since then, with more advanced detectors like the Pierre Auger Observatory in Argentina, we've detected several hundred of these UHECRs, and they continue to puzzle us. The Pierre Auger Observatory, which covers an area the size of Rhode Island with a grid of detectors, has been able to map the arrival directions of these particles with much greater accuracy. And the map it has produced is very strange. There doesn't seem to be a single powerful source nearby that is responsible for all of them. Instead, there appears to be a hot spot in the sky. A large patch of the sky in the direction of the constellation Centaurus seems to be producing more of these UHECRs than can be explained by random chance. This region of the sky does contain a number of active galaxies with supermassive black holes, which are one of the leading candidates for being the cosmic accelerators that could create these particles. However, the correlation isn't perfect, and the physics of how a black hole's jets could accelerate a single proton to such incredible energies is still not well understood. Another theory is that they could be produced by magnetars, the very objects we've discussed before, during their most violent giant flares. Or perhaps they are produced by the collision of two neutron stars. The mystery remains. These particles are the universe's most energetic messengers, and they are arriving at our doorstep with a story to tell about the most violent and powerful events in our local cosmos. We are still just learning how to read their message.
Let's now drift back to the invisible universe and think more about dark matter. The story of its discovery is a wonderful example of scientific perseverance. When Vera Rubin first presented her findings about galaxy rotation curves in the 1970s, her work was not immediately embraced. The idea of the universe being dominated by a mysterious, invisible substance was seen as radical and strange. Her meticulous observations were, for a time, largely ignored. But she was persistent. She continued to gather more and more data from more and more galaxies, and every single one told the same story. The stars were moving too fast. The visible matter was not enough. Today, her pioneering work is recognized as one of the most important discoveries of the 20th century, and the evidence for dark matter has become overwhelming. When we look at how light from distant galaxies is bent as it passes through a massive galaxy cluster, we can create a map of where the mass in that cluster is. And that map shows a huge, diffuse halo of invisible mass that perfectly matches the predictions of dark matter. The very existence of galaxies like our own is a testament to dark matter. Our computer simulations of the early universe show that without the extra gravitational pull of dark matter, the small density fluctuations from the Big Bang would not have been strong enough to pull normal matter together to form the large, beautiful galaxies we see today. Dark matter acted as the invisible seed, the gravitational scaffold around which all the visible structures in our universe were built. It is the quiet, unseen architect of the cosmos. And yet, we still have no idea what it is. It is the biggest and most profound missing piece in our model of the universe.
And what about dark energy? This is, if anything, an even deeper and more fundamental mystery. The discovery that the universe's expansion is accelerating was a complete shock. It was as if you threw a ball up in the air, and instead of slowing down and falling back, it just started to speed up and fly away from you faster and faster. It violates our everyday intuition about how gravity should work. The leading theory for what dark energy is goes back to an idea that Einstein himself had and later called his biggest blunder. When he first formulated his theory of general relativity, his equations suggested the universe should either be expanding or contracting. But at the time, everyone believed the universe was static. So, to make his math work, he added a fudge factor, a term he called the cosmological constant. It was a kind of energy inherent to the fabric of space-time itself, a repulsive force that would counteract gravity and allow for a static universe. When Edwin Hubble later discovered that the universe was, in fact, expanding, Einstein discarded the idea. But now, with the discovery of the accelerating expansion, the cosmological constant is back. It seems there really is a strange, repulsive energy woven into the vacuum of space, pushing the universe apart. But when physicists try to calculate how strong this energy should be based on our understanding of quantum mechanics, they get a number that is outrageously, comically wrong. It's about 120 orders of magnitude larger than what we observe. This discrepancy has been called the worst theoretical prediction in the history of physics. It's a quiet, colossal hint that our two best theories of the universe, general relativity and quantum mechanics, are deeply incomplete.
Let's conclude our tour of mysteries with one final, detailed look at the story of Oumuamua. The name itself is beautiful. It's a Hawaiian word that can be translated as scout or first distant messenger, and that's precisely what it was. It was the very first object we have ever seen that we know for sure came from another star system. It was a visitor, a tourist from afar. The strangeness of its shape, inferred from its wildly changing brightness, is one thing. The pancake or cigar shape is not something we see in our own solar system's asteroids, but the true mystery is that gentle push it had as it left our sun. It was accelerating away just a little bit faster than gravity could account for. This is called non-gravitational acceleration. For comets, this is normal. As a comet is warmed by the sun, its ice turns to gas, creating jets that act like tiny rocket engines. But the James Webb Space Telescope and others looked at Oumuamua with incredible sensitivity, and they saw no signs of the dust or gas that would make up a cometary tail. So it was accelerating without any visible means of propulsion. This has led to a quiet but intense scientific debate. The nitrogen iceberg theory is one of the leading natural explanations. The idea is that Oumuamua could be a chunk of solid nitrogen knocked off a Pluto-like planet in another star system. Nitrogen ice would vaporize when warmed by our sun, creating the push, but the resulting gas would be transparent, so we wouldn't see a tail. It's a clever idea that fits most of the data. The other more speculative idea from Avi Loeb is that it was an alien light sail. We will likely never know for sure. Oumuamua is gone now, traveling silently back into the interstellar darkness, leaving behind only a beautiful, quiet, and deeply intriguing puzzle.